Good morning to those of you that are here. Yes, congratulations first. What a good use of a comment. So I'm going to go ahead and get things rolling. This is what we got planned for today. We'll have a brief introduction. We're going to talk about the Bellwork from yesterday, which a few students had difficulty with. And the thing is, a lot of y'all didn't do it, but I only had 3 people that actually messaged me yesterday and asked for help with it. So that's kind of interesting. But we will take a look at that Bellwork. Next, I'm going to explain stoichiometry and talk about that just a little bit. It's a really long, scary sounding name, but it's really not. It's not anything to be concerned about. So we'll talk about that. And then I'm going to go over Simple Stoic worksheet, probably the whole daggone thing. And then at the end, if there's time, I'll give you guys a chance to ask me just questions and I'll answer them. First, some introductory stuff. I've been looking over. I estimate that maybe about 60% of my first period is actively doing work right now and are doing it on time and turning it in. It looks like only about 40% of my fourth period. So only about 40% of my fourth period is actually paying attention. I'm reading y'all's comments. I see you. It's peanut butter jelly time, but we'll get to work here in a moment. Here's the main thing. Yesterday, Google was down, and so because Buncombe County said, we're going to go Google Classroom all the way, and I said, okay, wink. Everything that I had was on OneNote, and you guys know that. But today is still going to be a catch-up day. So if you go to Power School or you see, and I've got to put a couple grades in. I ran out of time because I want to start this. And you see that you have an incomplete, that means that either A, you didn't do it at all, or B, you were missing a couple of things. You need to redo it. And when you redo it, you need to email me. Do not email me the assignment. Assignments still need to be posted in their specific place. But if you email me and just say, hey, can you regrade my moles to mass? Then yes, I will do it. Your email is a good way for me to keep track of that. So yeah, be doing that. Be doing things that you know you're supposed to do. So anyway, without further ado, let's go ahead and get things rolling. All right, so first thing, let's talk about that Bellwork from yesterday. So it was, and I'll be honest, this Bellwork was obviously written to be something that I went over in class, almost as a teaching method of technical difficulties. But that's not an option, so we're going to just do the best with what we got. So the Bellwork, it says balance, the following reaction. So let me see if I can write that reaction up here. So we've got Na plus Pb SO42, and that's going to yield something, PBI, 4. Dang, I really want that to fit on one line. Give me a second. And I'm sorry if it's a little small. I'm hoping you guys can see it on there. And I'm hoping that you're following along with me. A lot of y'all chose to do Bellwork by doing it on paper. If you did do it on paper, that's fine. Just make sure you insert the image into your Bellwork. Okay, I know it said do it in notes. I know that. But I really want you guys to just put it in your Bellwork page. And that's fine. So if you're following along with me now in your notebook, that is perfect. That's what I want you to do. So here we go. We got this equation. We got to balance it. Now, we have balanced a lot of stuff, so I'm not going to waste your time by balancing it right now. Instead, this image will load. There we go. I'm just gonna fill it in. So just trust me. We end up getting a 4 here. We end up getting a 2 over here, and everything works out. Everything is balanced. Okay. Let's move on to part B. Unless there are any questions. Okay, great. So now that we've gone over that, we'll go on to part B. And part B is where it gets a little bit tricky. And honestly, the way that I word the question, it's the best that I can do without just explaining it to you. So it says, if coefficients and subscripts actually represent moles, which they do. So like if I were reading this, okay, remember we talk about in chemistry, I don't want you guys to do 4NaI plus blank PbSO42. No. You guys have got to understand what all this stuff means and speak intelligently about it. So if I were looking at this, I would read it as a chemistry person. I would say, well, 4 moles. Now remember, moles are to molecules like dozen is to eggs. So when I'm saying moles, I mean a certain amount of molecules or atoms or whatever. So 4 moles of sodium iodide plus a blank means 1. You guys should know that. Okay? So, yeah, get some water. So 1 mole of lead 2 sulfate, I know it's lead 2, yields, okay, lead iodide plus 2 moles of sodium sulfate. So every time you see a coefficient, it really just means moles of something, okay? So what is the ratio of sodium iodide to lead iodide? So we're looking at a ratio of NaI to PbI. So this is what this means. In the last Chem Chat that we did, we talked about how we want to multiply by these conversion factors, where we say, look, this is equal to that. And so if you set up a conversion factor the right way, it's like multiplying by 1. Okay, so to give you an example, remember, 12 eggs equals 1 dozen. So that means that if I make a conversion factor that looks like this, oops, not 9 dozen, 1 dozen, that's like multiplying by 1 because that is equal to that. So it's like having 2 over 2 or 3 over 3. It still ends up equaling 1. So as long as you multiply by 1, you're good. So in part B, I'm asking you guys to make a conversion factor like that, in parentheses and in a fraction for NaI and PbI. So I'm going to have NaI, I'm going to have PbI. Okay, PbI 4. So here's the thing. If I look up in the reaction, what I see is 4 moles of sodium iodide are going to produce 1 mole of lead iodide. And I know it's 1 mole because there's a blank there, and blanks mean 1. So what I'm saying then is, okay, well, I have 4 moles of sodium iodide, and that's going to be equal to 1 mole of lead iodide. Okay, so 4 equals 1. So I went in parentheses and I said, hint, give me a fraction with moles, okay, of NaI over moles of lead iodide on the bottom. Okay, so I was looking for something like this. And then you have to know, well, what are the amounts? Once again, I look back at my balanced chemical equation and I say we have a 4 here. So I say, oh, well, then that's 4 moles for every 1 mole of lead iodide. So I'll put 4 over 1. And so this is all we were looking for in part B. So I boxed my final answer. There were a couple things that I had issues with. I just finished grading the moles to mass practice from earlier this week. I graded that before I went on stream. And one issue I had is you guys are not showing your work. This counts as showing your work. So if you're multiplying by conversion factor, I need to see that. So everything that you saw me write on the board in the last video, that's what I need to see from you guys. So if you got an incomplete and you're wondering, well, why did I get an incomplete? I did it all. That's why, because I need to see your work. All right. Now, another thing is please box your final answers, because as we get further and further into these mathy type of chemistry problems, I'm going to need to be able to find your final answer. So just make sure you put a box around it. Okay. Any questions about part B? I know that one's kind of weird. All right, we're moving on to part C. Moving on to part C. And guys, I am reading the comments. So if you have a question, don't wait for me to ask. Go ahead and ask it. Okay. And then I'll get to it as soon as I can. Let's look at part C. So if I have 2 moles of PbSO4 how many moles of sodium sulfate will this produce? So here's the thing. These type of problems are always going to give you one thing, and they're going to be looking for another thing. It's always going to be like that. So the way I think about it is, okay, what is this problem giving me? All right. And so for this problem, it says, well, I have 2 moles of lead sulfate. So I'll say, all right, well, I got 2 moles of lead sulfate. Okay. And the problem wants to know how many moles of Na2SO4 is this going to produce. So that's my target. I know I'm looking for moles of sodium sulfate. So now I'm looking for that. Now, this is exactly what we did with moles to mass because it goes back to this concept. Okay, if you guys remember, I told you whatever you're going from, whatever you're going to, you can get there by using one of these conversion factors. You always put from on the bottom, you always put to on top. So whatever you're coming from, the units, okay? So here, if I just gave you a number 2, and I just said, yeah, 2, there you go, 2. You'd be saying 2 what? To which I usually say 2 watermelons, because I have no idea, okay? 2 cows, 2 watermelons, we don't know. But when you put units, like what we have here, moles of lead sulfate, now I have some context. So another thing that you guys were doing that was not great on the moles to mass, and that's going to become even more important today, is you've got to give me units. I should never see a naked number. I should never see just a number 2 written on your work. You need to tell me 2 what? So here, whatever we're going from, we want to put on the bottom because then that'll cancel. And whatever we're going to is going to go on top. So when we look at this problem, I can see, okay, I'm trying to get rid of moles of lead sulfate. So what I'm going to do is I'm going to set up a conversion factor, and I'm going to put moles of lead sulfate. Wow, that looks great. Down on the bottom, okay, from, and then on the top of the fraction, I'm going to put what I'm trying to get to. I'm trying to get to, okay, sodium sulfate. So I'm going to put that on top. Okay, so look, from. So those units are going to cancel here in a second. 2. Those units won't cancel, so it changes it. It changes it into what the units are that we're looking for. Okay, so we got all this stuff set up, and now you're probably thinking, well, how do we know? How do we know what the ratio is? We just did that in part B. Whenever you're going from moles of something to moles of something else, you have to look at the balanced chemical equation. So as I look up here, let me move this into frame. There we go. As I look up here, I can see, well, how many moles of this? Oh, there's a 2 there. So for every 2 moles of sodium sulfate, I'm going to need 1 mole. See, there's a blank. 1 mole of lead sulfate. So I'm literally just looking here. I'll even fill it in. I hate to do that because I like to just leave blanks, but I'm going to fill them in. So the 2 comes from there, the 1 comes from there. So literally, in your calculator, if you needed it, 2 times 2 gives you 4, divided by 1, still 4. So my answer for part C is going to be 4 moles of sodium sulfate. And so there we go. Okay, there we go. All right. Now, yeah, one there. Yeah, it has to be a 1 because that's what we have up here in the blank. So a lot of people got confused because they said, well, why aren't you putting a 2 down here? Because the problem said 2. No. That's what they're starting you with. That's what they're starting you with. So if we think back to the egg example that we did earlier this week, if I tell you we got 36 eggs, okay, how many dozen is that? Well, when you're making your conversion factor, it's still going to be 1 dozen over 12 eggs because 1 dozen is equal to 12 eggs. It's not equal to 36. So we're not going to put 36 in there. We would put 36 eggs, okay, over here, maybe. All right. So keep that in your mind. Okay. So really, the only real difference between this and the problems we were doing earlier this week is that instead of just going from moles to mass, okay, moles of something to mass of something, now we have to go from moles of one thing to moles of another. And the way we do that is by using our balanced chemical equation up here. All right. So we're done with C. I boxed my final answer. I have all my units. This is what I mean when I say show your work. And so a lot of you, when I was grading moles to mass, literally all you would have is that right there. Or worse, a couple of you literally just did that. For what? Where did that come from? So you have to tell me. You give me all the stuff that I need so that I can grade you appropriately. All right, let's look at part D. Part D. Drop my marker. Part D. It says, if I want to have 3 moles of lead iodide, how many moles of NaI will I need to start with? So I'll say, oh, well, they give me a number. Every time they give me a number, I'm going to start by writing it over here. So I have 3 moles of lead iodide. Okay. how many moles of sodium iodide? So I know I'm looking for that. The problem is telling you that. It's always going to give you some number to start with. It's always going to give you some target. So now I'm going to use the same thing that we made in part B, actually. Because if you look, what you did in part B is you made a fraction that related moles of sodium iodide to moles of lead iodide down here at the bottom. And you already did that. But in case you've forgotten or you aren't writing the work, you're just sitting there staring at the computer and you're not writing anything down. Well, let's look again. Moles of sodium iodide, 4. For every 4 moles of sodium iodide, okay, I'll need 1 mole of lead iodide. I'm just getting it straight from my equation up there. So when we do the math, we see, well, 3 times 4 is 12. I'm sure you're all saying at home. 12 divided by 1 still gives me 12. So my answer then, 12 moles sodium iodide. Okay, questions so far? Type your questions. I got to go refill. I'll be right back. Yep, 3 times 4 equals 12. 3 times 4 divided by 1 gives us 12, so we're good to go. All righty, let's move on to part E. Now, E, it says how many grams of sodium iodide would I need for problem D? Because moles, that's not really something you can measure. Oh, goodness. Let's keep puppies away from computers. Those don't mix. So, like if I told you guys in a lab, okay, well, then if you want to make that much lead iodide, you need 12 moles. You're going to say, well, how do I measure that? Because mass, is not measured in that. We need grams, okay? So I'm going to use that 12 moles from the last problem. In fact, I'll go ahead and write it. And I want to find out, not moles, I want to find out how many grams of sodium iodide is that. Now, you all should know how to do this. Because whenever you're going from moles to mass or mass to moles, where do you always go to find the answer? I'll wait. Waiting on y'all. Whenever you're going from moles to mass or mass to moles, where do you look? At least take a guess. No, because I'm going to sit here and wait until you guys figure it out, because we literally did this on a whole worksheet earlier this week. Where do you look? Molar mass. And where does molar mass come from, Allie? Or anybody? The green sheet. Yes. Thank you, dear thugs. So glad to see dear thugs in the chat. So yeah, you use the molar mass, not atomic number. It's not up to Jesus. It's not the atomic number. Good job, Emily. It is the mass number. Because remember, like for oxygen, for instance, we used to say oxygen. Well, the mass number is 16, so that's 16 AMU. But now we know it's not AMU, it's grams per mole. Now, Emily's already done the work. I'm going to show it up here so you guys can see it. So because we have sodium iodide, that means we have to use the molar mass for sodium one time. Because look, there's only 1 sodium here. It's not like PbI4 or Na2 where there's 2 sodium. There's only 1 sodium here. So if we look, okay, great. So if I look on here, I can see sodium 22.99. And again, that'd be grams per mole. We'll fix it here in a second. Plus iodine. There's only 1 iodine, so I look in here and say, woo, iodine, 126.90. Okay? And when we add the 2 together, I'm going to use Emily's work, we get 149.89. So this gives us 149.89 grams per mole, wow, there we go, of sodium iodide. Now remember, our to, from to. We've got to figure out what goes where. So look, I'm going from moles. Okay, I'm going from moles. So I'm going to put moles on the bottom. Moles of sodium iodide is going to go on the bottom because then it'll cancel. I'm going to put grams of sodium iodide up on top because that's what I'm trying to get to. That's what I'm trying to get to. Okay, so I think I've got everything set up now, but we've got to put the numbers in. So look, 149.89 grams. Wow, that looks awful. Let's try that again. 149.89 grams per how many moles? What does per mean? P-E-R. Okay, the sound a cat makes all the time. What does P-E-R mean? Do y'all remember? Like 60 miles per hour. What does that actually mean? P-E-R. Per one. Good job. So what that means then is 149.89 grams for every 1 mole of sodium iodide. Okay? Per just means for every one. Remember I told you guys that story? 60 miles per hour means you can go 60 miles in 1 hour. Okay? Yeah, and that's the grams. So that's why that goes on top. So the moles end up canceling. So in your calculator, which I have right here, I would do 12 times 149.89, and I end up getting a massive number that's not going to fit in the little blank that I made. Let's just make it 1799. Okay, let's just make that 1799. That's close enough. Okay, but there we go. 1799 grams of sodium iodide. And this was actually for problem E. Sorry about that. We were actually doing part E. Okay, questions so far? We're about to move on to explaining stoichiometry. Any questions? What's our timestamp? There we go, 22. Okay. All right, let's take a look at the worksheet. I'm going to switch over to it. Now, I want to apologize because I even had my wife look over it. And yesterday morning when I was working on this worksheet, I was like, all right, I want to explain this just like if I were sitting in the room with them, just in case students aren't going to tune into the stream. They're not going to pay attention to me. You know, they're not going to come on. So I'm like, I need to write everything that I can. I'm going to color code it. It's going to be great. And then when I was done and I zoomed out at all the mess that I'd written on that worksheet, I was like, man, this looks like something a crazy person would write. It makes sense, but I'm hoping now it'll make a little more sense. So we're now on, no, I'm sorry. Before we do that, let me talk about stoichiometry. That's an O. So this is sort of like notes, but let me just explain this real quick. Stoichiometry is a really crazy name that really just means conversion factors. So a conversion factor, like we said, could be something as simple as just saying, oh, well, whatever my units, you know, that I'm trying to get to divided by my units that I had over here on that side. That's really what stoichiometry is. Stoichiometry is really just mole ratios from chemical reactions. So like in the past problem, we were talking about, you know, we had a certain number of moles of sodium iodide divided by 1 mole PbI4, I think it was something like that. That's all stoichiometry is. So if you guys ever see stoichiometry in a problem or on a question or on a worksheet like this, don't be scared of it. Stoichiometry is just a fancy way of saying this. That's what they mean. Using a chemical reaction to come up with these conversion factors. Okay, so once again, this or this, these are just called conversion factors. Because all I want you guys to think of when we're doing stoichiometry is just you're converting. You're going from units of one thing to units of another using the information that you've been given. Okay, so that's all it is. I mean, that's really all it is. So there we go. That didn't take very long. All right. I'm writing down my timestamps this time so that next time I can post them in. All right, let's take a look at that worksheet. And like I said, it maybe looked a little bit crazy, but I tried to write it as clearly as I could. So we're going to Simple Stoich worksheet. And we're going to look at problem number 1. Problem number 1, okay? Yeah, that's right. I got the Inca wrestling shirt on. So problem number 1 is basically what you're doing in all the other problems, but it's giving it to you in multiple steps. And then I'll show you guys how you could technically do it all at one time once you understand what the heck you're doing. But for now, let's see what we got. So it says the combustion of a sample of butane, which is C4H10, that's just lighter fluid, produced 2.46 grams of water. So what I need to start with, actually, because I'm going to reference it over and over and over and over again, that worksheet should be in your folder, Tony. In fact, I'm going to go look. I'm going to prove it to you. Have you restarted your computer lately? Have you synced your notebook lately? Because I'm looking at it in your notebook. So it should be there. It's called Simple Stoichiometry Worksheet. All right, so problem number 1. Okay, I need to write my balanced chemical equation because I'm going to use it about 10,000 times. I need a bigger whiteboard. It's one of those days, y'all. Day 1 of stay home, stay safe. Unless you can't stay home and you have to go get food or something. All right, so there we go. We've got our balanced chemical equation. Problem A says how many moles of water is formed. So here's the thing. We were given, if you right-click the notebook, like if you right-click my chemistry notebook, you'll see an option in there that says sync, S-Y-N-C, and it should be there. And it should be there. What am I missing? All right. So anyway, number 1, part A. So this problem gave us a number. In fact, I'm going to write it down right here. Okay. It gave us 2.46. I'm not talking to you, Google. It gave us 2.46 grams of H2O. And guys, I told you earlier, this is why it's so important to start being very specific with your units. Okay, very specific with your units. I was even looking at masses yesterday because I had to move some boards last night. And one of them was really heavy, and I looked it up online, and it was like, yeah, this is 110. That's how much it weighs. And I was like, 110? It's like, no way. It was a 2x12, so a board that's about this wide and that long by 16 feet. And it was like 110. I was like, 110 pounds? No way. And then I looked and looked and looked. I'm like, oh, it's in kilograms. So it was really like 250 pounds. But see, units are very important because I need to know what am I measuring in. So I've got 2.46 grams of H2O, and the problem gives us a target. The problem gives us something that we're looking for. It says how many moles of water formed. Okay, so I'm looking for moles of H2O over there. Now, guys, I said it earlier, and I hope you all are waiting by the keyboards because I'm about to ask you. Whenever you go from mass to moles of the same thing, or moles to mass of the same thing, where do you look? Where do you look? Whenever you're going from moles to mass or mass to moles, where do you look? Any guesses? Any guesses? There we go. Green sheet, the periodic table. It is all on there. All right, it's all on there. So if I look on the green sheet, I know I'm dealing with H2O. I'm going to cheat. Yeah, it's a white sheet right now. I'm going to cheat a little bit, but in case you're wondering, there are 2 waters here. So I'd look and say, or sorry, 2 hydrogens here. So if one hydrogen is 1.008, I'm going to multiply it by 2, because of the 2 there, plus 1 oxygen, which is 16.00. And so I'm just going to round it off. Okay, so I know it should be really, really specific, but I'm just going to round it off and say this is 18 grams per mole. But here's the thing, okay? Here's the thing. I'm not going to write it as 18 grams per mole because look, I'm going from grams. I'm trying to get 2 moles. So what I'm going to do is I'm going to say, oh, well, then in that case, I want to put grams on the bottom and I want to put moles on top. But remember, okay, in this problem, it says 18 grams. Okay, so I know that's the 18 goes down here per mole. Remember, per, it just means 1. Per just means 1. So what I would do then in my calculator, okay, and I've got it right here, is I'm going to say, well, I've got 2.46, move right, times 1, obviously, still 2.46, but then I'm going to divide by 18. Okay, and so look at what that did to our units. Grams of H2O goes away, and I'm left with moles of H2O, which is what I'm looking for. So I ended up getting 0.137. Let's just keep it simple. 0.137 moles of H2O. Okay. Tony, are you getting any sync errors? Like, do you see a symbol that looks like this? Do you have a symbol that looks like that? Otherwise, I recommend maybe just doing it on paper with us. Do it on a piece of paper with us, and then you can try and find it later. Okay? But I suspect that you have some type of error going on. Okay. So I just recommend following us on a piece of paper, and I'll try and work with you later, or you can call the tech department. They can help you and see if you can find it later. Okay. All right. Let's keep moving. So now I have this number. Now the next thing, part B. It says how many moles of butane was burned. So if we got 0.137 moles of H2O, okay, if we got that number, how many moles of butane? Now here's the thing. The problem gave us one number at the very top, and it said, oh, we have 2.46 grams of water. But here's the thing. Whenever I'm going from one substance, like water, to find amount of another substance, butane, you can't go from grams straight to moles of something else. That's what I'm trying to do, Drew. I'm going fast. So whenever you're going from some substance to another, you have to go through moles, always, because that's the way everything's written up here. So like, if you told me and said, well, I got 10 moles of H2O, then I could very quickly be like, oh, well, then you must have had 2 moles of butane. But see, now I'm telling you, we only have 0.137 moles of H2O, but I still know that 10 moles of water is equal to 2 moles of butane. So I can use that relationship, but you have to have everything in moles first. So from the last problem, I know that I'm starting with 0.137 moles of H2O now. I'm starting with it for this part of the problem, which we're on part B. Okay, we're now on part B. And so I'm starting with that, and the problem gives me a target. Remember, it gives you something to focus on. So if I look in the problem, it says, how many moles of butane? So I'm looking for moles of this, C4H10, moles of butane. That's what I'm looking for. And we can do that. Because remember, whenever you're going from moles of something to moles of something else, you have to use this. Okay, you have to use this. So I'll set it up. Okay, I know I'm going from moles of H2O, so I'm going to put that on the bottom because I want it to cancel. I know I'm going to moles of C4H10, so I'll put that up here on top. Okay, so again, if I want this relationship, this equal to this, because I want to multiply by 1, so whatever number I put down here must be equal to what's on top. 12 eggs is equal to 1 dozen, and vice versa. So if I look up here, 10 moles of H2O are equal to every 2 moles of C4H10. Now I'm going to pause. Does everybody understand what I just did and why I did it? Because if not, you need to speak up through the internet. Okay, I guess not. So what I would do in my calculator, Okay, I've got my calculator here. I'm going to take 0.137 times 2, enter, divide it by 10, enter, and I get a really small number, but that should make sense. I'm not starting with a whole lot of water. 0.137 moles, that's not much water. Okay, and so I'm not going to end up with very much butane either. So what I ended up getting is 0.0274. And once again, this is why it's so important to have units, so that when you're doing your work, you don't get confused. I don't want you guys to be like, well, 0.137 what? I don't know. You've got to keep track of what you're doing, because otherwise you're going to get very confused. So we ended up finding that. So what that means for the problem that we just did is it means, look, if I started with 2.46 grams of water, I can make 0.0274 moles of butane. Okay, or I would use 0.0274 because we're starting with butane. We ended up with water, but we started with it. So that's what all that means. Let's look at part C, and I'm moving. Let's look at part C, and I'm moving. How many grams of butane is that? Good gracious. So annoying. Why can't we just stop with moles? Because again, if I ask you guys moles, and I'm like, all right, what is a mole? You're going to sit there, okay, until drool starts running out the side of your mouth. But if I tell you grams, grams is something you can understand. Grams is something you can measure on a scale. So I'm going to use the number from the last problem, because I just got 0.0274. So I just got, it's not an animal, it's a unit. I don't want to write it there. I'm going to write it here. Okay, and I want to find out how many grams of C4H10 it is over here. So I'm looking for number of grams. Now remember, when you're going from moles to mass or mass to mole, periodic table. So we'll look in our periodic table. I want you guys to try it. I hope you're trying it. I hope you're following along with me. What a shame. Sorry, I just read an email from Miss Robinson. So we got moles, we're going to grams. And so what that means is we're going to have to do just a little bit of math to figure out what all this stuff represents. So I've got 4 C's. And I look on my periodic table. I see that the molar mass for carbon is 12.01. So I have 4 times 12.01 plus 10 H's. So I'll have 10 times H, which is 1.008. I don't need to look. Okay, it's just habit. All right, and so I'm going to do that math in my calculator really quick, and I hope you guys are following me at home. If you're doing this on paper so that you can submit it later, that's great. If you're doing this on, you're trying to write it on your worksheet with me, that's fine too. Okay, so Drew, I'm going to check your number, no offense. I want to make sure I got the right thing. 2 calculators are always better than 1. And I got 58.12. Ooh, I got a slightly different number, but I don't know. It's the same thing. So 58.12. Now remember, this is grams of C4H10 per 1 mole of C4H10. So here's our conversion factor, and it's actually set up the correct way, because if you remember, we're trying to cancel moles C4H10 on the bottom, and we're trying to get to grams of C4H10 on top. So that works up. That works out. Okay. And so there we go. 1 mole, and then 58.12 up on top. Getting a phone call. Gee, how rude. See if you can find out what the answer is. It's Buncombe County Schools. Don't they know I'm teaching? Oh, yeah. I can read the email. I don't need to listen to the message. They usually will email us, and then they'll call us and give us the exact same information. All right, so let's see if I'm getting what you all are getting. Times 0.0274, enter. I get 1.59. There's, well, right now I guess you're not writing. You could erase all my scribbles. that don't apply to the answers, I guess, or you could erase the whole daggone thing. I don't really care. But when we get to part 2 and 3 and 4 and 5, then maybe you can start writing. I'm kind of hoping you guys are following. That's all, Tess. I just want you guys following. Are we dying? Yes, slowly every day. Okay, you're not immortal. All right, so after that philosophical quandary, I got 1.59. Guys, don't go so crazy with your decimals on this. There's no reason to do that. Just keep it simple. So I got 1.59 grams of C4H10, which is not a whole lot. That's not a whole lot. All right, let's move on to part D. Okay, let's move on to part D before you guys start getting me depressed. All right. Proud to be a Jet, guys. Proud to be a Jet. If I need to go change and put on my Proud to be a Jet shirt, I will. All right, we're looking at part D. Because part D is saying, okay, well, how much oxygen was used up in moles? Okay, how much oxygen was used up in moles? Now, here's the thing. That just gave us a target. Okay, we know now that we're looking for moles of O2. Well, Mr. Aaron, why isn't it just moles of oxygen? Because if I look in the problem, it says O2 up here. And we know that the 2 is there because Brinkelhoff. Okay, so that 2 is there because of Brinkelhoff. So I've got moles of O2 that I'm trying to find. So what are we going to start with? Because we have a lot of numbers at this point. I mean, if I look back, we've got 1.59 grams of C4H10. I've got moles of C4H10. I have moles of H2O. So we can start with a lot of different numbers, but a couple of them are going to be a lot more useful. Remember, whenever you're going from trying to get to one substance to another substance, whenever you're going from something to something, you want to use moles. So like I could start with grams of C4H10, but that's not going to be very useful because I still have to convert it to moles. Whenever, look at me, I'm looking directly at camera. Whenever you are going from moles of something to moles of something else, it has to be in moles. You can't shortcut and say, oh, well, I want to go from grams of water to grams of something else. No, you cannot do that, okay? You always have to go through moles because this up here is moles, okay? There you go. I stared deep into your soul. So I did this 2 ways on the worksheet. I'm only going to do it 1 way right now, and you're going to have to trust me. I'm going to start with moles of C4H10 because that's what you guys are typing in on there. So I'm going to say, all right, well, let's look. 0.0274 moles of C4H10. And look, going from moles of something to moles of something else. That's good. That's what we want to do, okay? Because now what I can do is I can make a conversion factor that says, well, I want to get rid of moles of C4H10, so that's going to go on the bottom, so it'll cancel, okay? And I'm trying to get 2 moles of O2 up on top, okay? Trying to get to that. And then, where do I get these numbers? Anybody? Where do I get these numbers right here? How many moles versus how many moles? Where does that come from? I guess there's a little bit of a delay, but I'm hoping it's just the delay. Yeah, the balanced equation. Because if I look back up here, I can see that I have a 2, okay, in front of C4H10. So that's going to stay next to C4H10. Yep, we use the coefficients. Moles of O2, 13. Woo, moles of O2. All right. So I've got everything that I need. I know it looks a little like a B. It's a 13. There we go. That looks better. So in my calculator then, I'm going to say, well, 0.0274 times 13, enter. I always like to split up my calculations. It probably works, but I just, like if you do this times this divided by this, it probably works if you do it all in one line, but I don't like to. So I got 0.1781, or how about just 0.178 moles of O2. Okay, moles of O2. Now, you could do this exact same thing using moles of water. In fact, I did it on the worksheet. So if you want to look through my scribbles, you can find it on there. But you can do it using moles of water and do the same thing. See, look, I'll prove it to you. So if I look back, we had 0.137 moles of H2O. Okay, I had 0.137 moles of H2O. When I make a conversion factor, it's going to be 13 moles of O2 over 10 moles of water when I make a conversion factor. So it's okay, 0.137 moles of H2O times 13 moles of oxygen divided by 10 moles of H2O. And what do you know? I get the exact same number, 0.178. So you can do it as long as you start with moles of something, you're going to moles of something else. All right, we got to keep moving. Let's move on to part E, which is probably going to ask us for grams or something like that. Probably. Let's see. Yep. How much oxygen was used up in grams? So we got a target. Grams of O2 is what we're going towards. We just found out, okay, that we have 0.178 moles of oxygen. Okay, so that's kind of useful. And so again, we're going to make another conversion factor. See, all of these, even though it's called stoichiometry and it's really scary sounding, all of these are the same thing. Starting with something, going to something else, and setting up your conversion factor correctly. So I know I want moles of O2 on bottom, and I know I want grams of O2 on top. Now, we could do the math again, and I could show you that because this is oxygen, you got to go to the periodic table, you got to find the molar mass, you got to multiply it by 2 because there's 2 oxygens, but just trust me, it's 32. 32 grams of oxygen for every 1 mole of O2. And again, that just came from the periodic table. And so I say, oh, well, then 0.178, which I have in my calculator still, times 32, enter 5 point, let's just call it 5.7. I got 5.7 grams of O2. Okay. And that's part E. Questions, comments? Today's sponsor, Inca Wrestling, okay, because they gave me this free t-shirt, so I guess I can consider that a sponsorship. Okay. Okay, great. Yeah, dogs are usually very active for about 2 hours and then they calm down. No what, Drew? No questions? All right, great. Let's move on to number 2. And things are going to start moving a little more quickly, so I hope you're paying attention. All right, so we're looking at number 2 now. That means we have to start with a new balanced equation. But I think it's already been balanced for you, so that's kind of nice because we've done so much balancing. Do we really need to keep doing it? No. So I can see that I have 2 moles of sodium hydroxide plus, sulfuric acid. 1 mole of H2SO4 is going to give me 2 moles of H2O, okay, plus 1 mole of sodium sulfate. Like I said, we're doing problem number 2 now. Now, if you really want to see the long, drawn-out way of how I do this, you can. It's in my scribbles. It's much more linear, like it just goes from left to right. It should be a little bit easier to follow. But basically, you can do this in multiple steps like we did in problem number 1. But what I think I'm going to try and do is I'm going to try to do it all in one go. Because as you guys get better at this, and I hope, I wish there was a way I could instantly poll the class, but I can't because I don't have enough subscribers. But I hope that you guys understand a little bit better about what we did in problem number 1. It's always going from something to something else. And you have to know, when do I use the periodic table? When do I use the balanced chemical equation? You just have to know when to do that. And that just takes practice. So for problem number 2, if you want more detail and specifically like how to do it in several steps, you can. I'm going to do it in one move. Okay, I'm going to do it in one line of equations. All right, so problem. It gives us a number because as I'm reading it, it says how many grams of sodium sulfate. Hey, there's our target. Okay, I don't know, something like 1,000, I think, Drew. I don't think I'm going to get 1,000 subscribers to my little pokey Buncombe County Schools YouTube channel. So once again, it's giving me a target. How many grams? I'll write it over here. Of sodium sulfate, okay? So grams of Na2SO4, that's our target. We keep it in frame. would be formed if you start with 200 grams of sodium hydroxide. So look, they're giving us a number. They're giving us a number to start with. How nice of them, okay? How nice of them. Do not make 900 accounts. So I need 200 grams at the beginning. Is it okay if I just leave it as 200 grams? No. Okay. We have got to be specific because we're going to be going from something all the way to something else. You've got to be specific about what you're doing. So I want to say 200 grams of, problem says, sodium hydroxide. So I'm going to put NaOH. Okay. So we're starting with 200 grams of sodium hydroxide. We're trying to get all the way over here to grams of sodium sulfate. Now, here's the thing. If I want to go from one substance to another, can I go from grams to grams? Type in your answer. Can I go from grams to grams, from something to something else? I'm serious. I need you guys to answer me. Tell me what I would have to do. If I wanted to go from something to something else, what would I have to do? Yes, good job, Elena. You have to go to moles, okay? You have to go through moles first, all right? So what that means then is somewhere kind of here in the middle, I'm going to go from moles of sodium hydroxide to moles of sodium sulfate. But we've got to get everything into moles first. So here's my first conversion. Red. Here we go. My first conversion is I want to get grams of sodium hydroxide into moles of sodium hydroxide. So my first conversion is I'm going to say, well, I'm trying to get rid of grams. So I'm going to put grams of NaOH on the bottom. I'm trying to get 2 moles of NaOH. So I'm going to put that up on top. Remember, from, to, because I'm trying to get to that. Okay. And so, oh no, what do I do? Where do I get grams of NaOH, y'all? Where do I get it? Good job, Kevin. Yeah, we're going to go from grams to moles and then back to grams again. But where do I get grams of NaOH, y'all? Periodic table. That's right. Green sheets. That's right. So I have 22.99 for sodium. You can see on the periodic table, that's the molar mass for sodium. 16 for the 1 oxygen. 1.08 for the 1 hydrogen. And I'm going to add them all together. No, I'm not. I already know the number. It's 39.998. And that's what's going to go down here on the bottom. Is that too small? Can y'all read that at all? Or is that way too small? Let's change the setup just a little bit. Can y'all read that, or is it too small? And bad handwriting, because it's me writing. Okay, well, nobody's saying anything, so I guess you can read it. And again, this is 39.998 for every 1 mole of sodium hydroxide. Okay, so look, we got a conversion factor set up. Now, you could go in your calculator and, do the math and hit enter and then say, okay, what have I got? Okay, I'm sorry, Drew. I'm trying. I'll try to read out what I'm doing at least. But I need to write it this way for what I'm about to show you. So here's the thing. All right, train of thought. Come back into the station. Oh, so you could hit enter and then say, okay, well, now I have moles of sodium hydroxide. What am I going to do next? But I'm just going to keep it all together because in my mind, I know what I'm doing. So I'm going to set up another conversion factor. So what I'm going to do is I'm going to say, all right, at this point in the problem, okay, I'm sorry. I've got it. I'm running out of room in my real life space here, so I'm trying to fit it all. See, that doesn't. I can try and do that. There we go. So here's the thing. I know that I just canceled out grams. Does everybody see that? Because look, grams is with grams. So if I were to stop right here at the red and not go any further, I would have moles of NaOH. But instead, what I'm going to do is I'm going to say, well, I don't want moles of NaOH. I'm trying to get to Na2SO4. I'm trying to get to sodium sulfate. So my next conversion factor, I am going to want to cancel moles of NaOH. So I'm going to put moles NaOH on the bottom. And then on the top, I'm going to put moles of Na2SO4. Everybody see? So now what I'm doing is my moles of NaOH is on the bottom, so that'll now cancel, and I'll get to moles of Na2SO4. Now, where are these values going to come from? Moles of something compared to moles of something else. Where can I get those numbers from? I'm level my whiteboard out a little bit. No, I can't. All right. If I want to compare moles of something to moles of something else, where can I find those values? Yes, the equation. Now the answers are coming in. So if I look up here, here's the information for NaOH. Here's the information for Na2SO4. And so in reality, 2 moles of NaOH is going to go on the bottom for every 1 mole of Na2SO4 up on top. Now, once again, if I stopped right here, let's look at what would cancel. Because if I were to stop right here, look, moles of NaOH, moles of NaOH. So if I were to stop right there, I would have moles of Na2SO4. And that's not what we want. We don't want moles, we want grams. So we need one more conversion factor. Okay, we need one more conversion factor to get to grams of Na2SO4. And I need one gram. So we're trying to get to grams Na2SO4. So we need one more conversion factor. And so I'm going to set it up. Okay. I think that's enough room. There we go. So look, I'm trying to cancel moles of Na2SO4. So I'm going to put moles on the bottom. And I'm trying to get to grams. That's not going to be enough room. Grams of Na2SO4. So I'm going to put that up on top. Okay. And once again, whenever you're going from grams to moles or moles to grams, periodic table, I'm sure is what you all are saying. And so if I look at the periodic table, I can do this. This one's a little bit harder. In fact, I'll write it up here and you guys can see it. So look, I've got 2 NAs, okay, Na2. In fact, I'll write it this way. I have Na2. So what that means is I'm going to do 2 times 22.99 plus only one S. So if I look at my periodic table, I see it has 32.07. I don't need parentheses for that. So I'm just looking at my periodic table. Oh, there are 4 of them. So now I've got to say, oh, well, now it's O4. So if I look, okay, O is 16, but there are 4 of them. So I'm going to do 4 times 16. And so what do we end up getting? We end up getting some number. I got 142.05. Okay, so when I do all this, I get 142.05. Now remember, that means 142.05 grams per 1 mole of sodium sulfate. 142.05 grams of sodium sulfate for every 1 mole. Grams per mole, okay? Although earlier we did moles per gram, but that's okay. You can do that. So notice, we have now canceled everything that we don't want, and we're left with what we do want. We started this problem way back here at the beginning. We had 200 grams of NaOH. Grams of NaOH canceled. Moles of NaOH canceled. Moles of Na2SO4 canceled. And we're left with our units of grams of Na2SO4. So you can do it all in one go. You just got to be kind of careful with the calculator. So I'll tell you exactly what I'm typing in the calculator to get an answer now that I've scribbled all over this. So in my calculator, I'm starting with 200. I'm going to multiply by 1. I can. I'm going to divide that by 39.998. And every time I do one calculation, just for my sake, I hit enter. So every time, 200 times 1, enter. Divided by, because I'm keeping my answer, 39.998, enter. Times 1, enter. Divided by 2, enter. Times 142.05, enter. Divided by 1, enter. And I get 355.1. 355.1. And guys, oops, that was awful. I've said it and I'll say it again. Please be intentional with your units. Be good with your units. Box your final answer. I'm showing you exactly the type of work I want to see on your paper, if you handwrite it, or on your digital version. I have got to see all this work in some way. So if you got an incomplete and you're wondering why, that may be why, because you're not showing your work the way I told you to. Okay. And remember, incompletes during this remote learning period count as zeros. So an incomplete is like getting a 0. It just means you didn't do it or you didn't do it right. All right. So we got 355.1. Okay. In the chat, okay, because I want some participation here. 1 means I am so confused. 10 means this is really easy. I think I get it now. Okay. So rate from 1 to 10. Tell me how you're feeling. I'm going to go get some water because I'm out again. Wow, Drew, that's really specific. Okay, I can handle 7s. We can go and do another one. I can handle a 7. 6, we'll get you there. 6.78. Okay, good. All right, let's go ahead and do another one if there are no questions about this. Let's look at number 3. This is one you've never seen before. Dun, dun, dun. But it's the exact same thing. Literally, once you understand how to do one of these, all of them are exactly the same. That's why I don't really like this worksheet. I kind of wish it had a little more variety to it, but you know, what are you gonna do? All right, so let's look at number 3. Number 3. All right, they give us this equation. I better write it. So we have 1 mole. Is it balanced? Yeah. We have 1 mole of Fe2O3. We have 3 moles of hydrogen gas. This is giving us 2 moles of iron and 3 moles of H2O. Okay. All right. And the problem says, notice, just like every other problem like this, notice it gives you a target and it gives you a number to start with. So our target, let's start with that. Calculate how many grams of iron. All right, pause. I know that way over here, I'm going to be looking for grams of iron. Okay, that's out of frame. Come on, get in here. So I know, look, I'm looking for grams of iron way down here at the end. Can be made from 16.5 grams of iron oxide. This is iron 3 oxide because it's a transition metal and you have to use Roman numerals. Iron 3 oxide. Okay, same thing as the last problem because we can't just go from grams of something to grams of something else. Everything has to go through moles. Okay, everything has to go through moles. So first thing I'm going to do is use blue for probably for the whole problem. So first thing I'm going to do, okay, is I need to go from grams of iron oxide into moles of iron oxide. We've got to go through the mole. So I'm going to put moles down here in the bottom, moles of Fe2O3, and I'm going to put grams of Fe2O3 up on top, okay? And so once again, this comes from the periodic table. I'm not going to waste your time writing it out. If you don't know how to get grams per mole or moles per gram by now, you need to go back and do the moles to mass worksheet because you should know how to do it. So I'm going to do it really quick. We'll see if it's the number that you guys are getting. Please, if you're doing this with me at home, you should not just be sitting there waiting for me to give you the answer. I hope that you are working with me and you're typing in your calculator, you're looking at your periodic table, you're trying to find this information on your own. Okay, so I'm going to see what I get. And I get this number. I got 159.7. Why, thank you, Tess. Yeah, that's my fault. Tess said, if you can't see comments at home, Tess said, shouldn't grams be on the bottom? Yes, they should. I should have tea in this cup instead of water. Maybe I'd wake up and do a little bit better. So yeah, we want grams to go on the bottom because we're trying to cancel that. We want to get 2 moles, so we want moles to be up on top. So yeah, that is completely my fault. So I got 159.7, and 159.7 is going to go with the grams, because remember, 159.7 grams per mole. That's what it means. Okay, so 1 mole goes on top, 159.7 grams goes on the bottom. Okay, so now that we got that, next, what I'm going to do, because in my head, I don't want to cross everything out yet, but I know that I just canceled grams, so I'm left with moles. But I don't want moles of iron. I'm trying to get to grams of, sorry, I don't want moles of iron oxide. I want just grams of iron. So the next conversion I'm going to do is going from moles of iron oxide, which I want to put on the bottom. I'm paying attention now. I want that to go on the bottom because I want it to cancel. Okay. And I want to get 2 iron, so I'm going to put moles of just iron up on top. So I'll put moles of Fe up on top. Okay. And now, where do we get these numbers, y'all? This came from periodic table, but where does this come from? If I'm going from moles of something to moles of something else, where do I get it? The equation. That's correct. Okay. Okay. So anyway, what that means is I look up here and I can see, all right, iron has 2 moles in front of it. So I'll put a 2 moles of iron. And then I see, all right, well, iron oxide, oh, it's only 1 mole of iron oxide. And so by doing this, okay, what that's going to do to us is I'm going to say, all right, well, moles of iron oxide is going to be canceled. Okay, look at where I'm pointing, cancels, and now I'm left with moles of iron. But I don't want moles of iron, I want grams of iron. So I've got to do 1 more of these. Okay, I've got to do 1 more of these where I say, all right, well, I want moles of iron to go on the bottom because I want it to cancel. And grams of iron, there's only 1 of them, is 55.85. Because from the periodic table, I know 55.85 grams per mole is what's correct for iron. So I'm just getting that from the periodic table. So grams per mole. There we go. Now look, I'm going to do all this in my calculator. Okay. But look at what cancels. We started with grams of iron oxide over here. And then grams canceled. Then we had moles of iron oxide. Like if we were to have stopped the problem, okay, right there, and we just said, nope, that's it. That's all I want to do. I'll stop right there. Then we would have had moles of iron oxide. But look, then we canceled moles of iron oxide. And we didn't stop there. Then we said, all right, well, now we got moles of iron. So if I were to stop the problem right here, you would have moles of iron. Like if you stopped in your calculator and wrote a number down, that's what you'd be left with. But look, we canceled moles of iron and we were left with grams of iron. So everything that we did in this whole problem is so that we can get grams of iron, because that's what the problem is looking for. So I'm going to go on my calculator here. Okay. I'm going to start with 16.5. Okay. I'm not going to multiply by 1. You can, but I'm going to do 16.5 divided by 159.7. Okay. Then I'm going to multiply that by 2. Then I'm going to multiply that by 55.85. Enter. And I get 11.5. There you go. And that's how you do that problem. Give me a rating of how that problem felt. 1 to 5. 1 to 5. 5 being that was really easy. I think I get it. 1 meaning like I am still super confused. So rate that one 1 to 5 on how you feel about it. Yeah, that's what I'm doing, Kevin. It's just I don't have time to explain the math. I'm just trying to explain it to everybody. That's why for some students, I'll just explain and say, look, you do this times this, enter. Then you divide by this, enter. Then you multiply by this, enter. Like that's why I explain it that way. Oh, Tony, we got to get that number up. That is not high enough. But yeah, if you think about it, every time you're doing something, you're multiplying by things that are on top, you're dividing by things that are on bottom. But it does work better if you go from left to right. Okay, it does work better if you go from left to right. All right. Don't worry, we're gonna do another one. How many we got on this? We only got a couple more. Let's go ahead and knock it out. Ugh. The next equation is so long. All right. Let's keep going. Let's look at number 4. Let's look at number 4. And I hope you're following with me. I don't like that. And the reason I'm writing it is just so I can point to it. That's the main thing. That's the main thing. I did it again. All right. So let's get things going. Yeah, we're gonna keep grinding. We peaked at 12 people, 9 o'clock in the morning, and the number just keeps going down. So hopefully people are gonna watch it later. So this has already been balanced for us. That's great. Thank you, problem. But it's still gonna be the same thing. I look at the problem and it gives us a target. It says calculate how many grams of sodium. I'm sorry, how many grams of iodine. There's my target. Grams of iodine are needed to prepare 28.6 grams. Oh, really? We hit 14? Wow. To get 28.6 grams of iodine chloride. Okay, so they gave us a number to start with. 28.6 grams of ICL. Okay? All right. So now that we got this, we know we're going here. It's not going to be that bad. I'm going to put the blank above because I'm probably not going to have room to write it. So once again, first things first, we got to go from grams to moles. After we go from grams to moles, we're going to go moles of one thing to moles to the other. After we do that, we're going to go from moles to grams, and then we'll be done. So that's our game plan. We can do it. So here we go. Start the fun. So the first thing, in tests, I'm paying attention this time, is I'm going to put grams on the bottom because I'm trying to cancel out grams. So I'll put grams of ICL on the bottom. I know I'm trying to get to moles of ICL. I'm going to put that on top. Heck, let's go ahead and write the whole thing. Let's go ahead and write the whole thing out. The next thing I'm going to do is I want to get rid of moles of ICL, so I'm going to put that on the bottom. And I know I'm trying to get to moles of iodine, so I'm going to put that on top. Okay? But wait, there's more. Because the last thing I'm going to do is I want to get rid of my mole. Let me try that again. I want to get rid of moles of iodine, and I want to get to grams of iodine. So I'm going to get rid of moles by putting that on the bottom. I want to get to grams of iodine, so I'm going to put that on top. So that's our game plan. Let's fill everything in and see if we can do it. So my first thing is a mole to gram conversion or gram to mole conversion. And again, we know to get that from the periodic table. So if I look at the periodic table, I can see that I have one I, okay? I actually have two I's, but in the problem, we have one I. And I can see it's 126.90. plus 1 chlorine, okay? And that is 35.45. So we end up getting a number, and I hope you all are typing at home. I get 162.35. Now let's think about what that number means. That means it's grams per mole for iodine chloride, which is really weird. Iodine and chloride should not bond, but for this problem, they are. All right. So we end up getting that grams per mole. But again, because grams are equal to 1 mole, 160.35 grams are equal to 1 mole, we can write it that way, or we can flip it and write it the other way. And that's what we're doing here. We're going to put 1 mole on top, and we're going to put 162.35 on the bottom. Okay, so 1 mole per that. It's the same thing. 12 eggs is equal to a dozen. 1 dozen is equal to 12 eggs. So you can flip it however you want to. Next thing, moles of one thing to moles of another. So I look at my chemical equation. I look up here, moles of iodine. It says 2. Hope you can read that. But there are 2 moles. Ooh, I put an I, and I meant to put an I2, and nobody said anything. So look, it's an I2, because as we can see in the problem, it's I2 because of Brinkelhoff. I'll just fix that really quick. So every I should have a little 2 next to it. Y'all understand that? It was Brinkelhoff and I missed it. That was me. So there's a little 2. All right. So we get 2 moles of iodine, okay, and moles of ICL. Ooh, 5. Wow, what a big number. So we have 5 moles of ICL up on top, okay? The next thing we got to do is look, we've got moles. So like, again, if I were to stop the problem, you got to think about it that way. If I were to stop the problem right here, okay, we would have canceled grams, we would have had moles, canceled moles, but then we would have ended with moles of iodine because we wouldn't have canceled that yet. But we don't want moles, we want grams. So this last thing is going to get us from moles of iodine here, okay, right there, into grams of iodine. All right. So once again, this comes from the periodic table. Because we're dealing with I2, that just means I'm going to do 2 times 1 iodine, which is 126.90. And so we end up getting a number. Here's my calculator. And I get 253.8 grams per mole of iodine. And that is not in the frame, but you guys will be okay. Well, maybe not. Hold on. Come on, stool. That's how you go. Oh, there it goes. Okay, there it goes. So anyway, we got that down there on the bottom. All right, so I'm going to plug that information in. 253.8 grams per 1 mole. Good, good meme, Drew. I appreciate that. So, just so people that are rewatching this later can see what the heck we're doing, okay, we know that this right here came from the periodic table. Came from the periodic table. This here, okay, came from chemical equation. So it came from this chemical equation up above. And then this here, once again, this came from periodic table again, okay? So you just got to know where to look, okay? Moles to mass, mass to mole, periodic table. You're going from moles of something to moles of something else, chemical equation, okay? So now that we've done all this, I hope you guys are ready to calculate, because I am. So I'm going to do 28.6 times 1 divided by 162 times 2 divided by 5 times 253.8 and divide by 1. I'm not going to do that. I'm not interested. And so when I do everything, I get 17.88. I'm just going to make it 17.9 because I can. 17.9 grams of iodine in the very end. Okay, rate how you felt about number 4 from 1 to 5 quickly. Give me a rating, 1 to 5, quickly. on how you felt about that problem. I did it a slightly different way, but it's the same thing. Good. I like to see those numbers going up. Even though Drew went up by 1/100th. So Kevin's gone up by 0.5. Caitlin's gone up by, I can't do that math, 0.35. All right, Tony, where you at? You gave me a 0.89 last time. Where are you now? Uh-oh. Did we lose him? All right. Well, anyway, I'm going to go ahead and erase this. We'll look at number 5 as we wrap this thing up. Or get close to wrapping it up. Man, red does not want to erase. All righty. Number 5. Yeah, number 5 is a lot smaller. That's nice. All right. So we got 4 moles of ammonia. Ooh. Plus 5 moles of oxygen gas is going to give us 4 moles of nitrogen monoxide, okay, plus 6 moles of water. And guys, I hope that what I just did, makes sense. If you are having trouble with naming, don't. Okay, we've gone over that. We spent a lot of time with that, so make sure you review it and you understand it. So you at home should be able to say, at worst, maybe say nitrogen trihydride. I know it's ammonia. We know this is O2. It's just oxygen gas. We know this is nitrogen monoxide. I use the prefix here because it's covalent. And we have water, because we know it's water. It's probably going to be a liquid at room temperature. Oops, sorry, stool. All right, let's go ahead and get things rolling. Let's look at what our target is. How many grams of oxygen? All right, I know what I'm shooting for. How many grams of oxygen, okay, are needed to react with 56.8 grams of ammonia? Okay, so look, we got a target. We have a number to start with. Okay, so if I look on here, I kind of know what I'm doing. It's the same process. We're going to start with this. We're going to go to this. Okay, we're going to start with this. We're going to go to that. All right. Yep. First things first, I know I've got to get from grams to moles. I'm going to put grams of ammonia on the bottom. I'm going to put moles of ammonia on top. And again, the idea here is you want to cancel what you're not wanting by putting it on the bottom, and you want to have what you're kind of going towards up here on the top. So grams of NH3, it's not that hard. Nitrogen, I look, it's 14.01. There's only one of them, so 14.01. Plus hydrogen is going to end up being 3 of them times 1.008. And so we end up, wow, what a great 8 I just drew. Okay, so $17.03. I'm just going to round it. 17.03. Okay, grams per mole. And again, this is grams per mole for nitrogen trihydride or ammonia. So 17.03, the grams goes with that. Per mole just means 1. Per mole means 1. So that's why I put that 1 there. Next thing I'm going to do is I'm going to go from moles of one thing to moles of another, because I'm trying to get over there to oxygen. So I need to say, okay, well, I'm going to put moles of NH3 on the bottom, and I'm going to put moles of oxygen up on top, because look, by doing this, I can cancel NH3 and end up with oxygen. So again, when I'm going from moles of something, I need to go to moles of something else. I'll look up here. So moles of oxygen, 5. Okay. Moles of ammonia, 4. Yeah, just comes from up there. Okay. Next thing, I need to get to grams. I don't want moles. So if I were to stop right now, and you could, but it wouldn't be the answer. you would end up with moles of oxygen. See why it's so important to write all these units in here so you don't get confused? So if I were to stop right now, I would have canceled a bunch of stuff, but I'd still be left with moles. So we need to finish up. We want to get rid of moles of O2 so we can get grams of O2. All right? And we can get our answer over here on the side. There's my equal sign. All right, so grams of O2. This isn't that confusing. We've done this one before today, actually. One oxygen would be 16, but because there are two of them, we do 2 times 16, so we get 32.0 grams per mole. And once again, per mole, 1 mole, okay? All right, so there we go. We got everything written, and we can go ahead and start doing some math, all right? So 56.8, I'm not going to multiply by 1. I don't need to do that. I know what it's going to be. Divided by 17.03, okay, times 5, divided by 4, times 32, divided by 1, but I'm not going to do. So I end up getting 133.4. And I'm going to box my final answer. Please box your final answers, okay? And that's what I did here, okay? And look at what happened to all the units. This is why we're doing it in a specific way. Look what happened to the units. We started with grams of NH3. Nope, canceled it. Then we had moles of NH3. Nope, canceled it. Okay, then we had moles of O2. Canceled it. Then we ended with grams of O2, and that's the unit that we were looking for. So that's why this is so important. That's why we write it such a specific way. Okay, that's why we write it that way. 4.9 for Drew. You guys chat in. Where you at? How you feeling with it? 1 through 5. Because I'm going a lot quicker now. And we've got one more. Good. Now here's a question. I'm gonna just spice it up just a little bit. Okay. If I asked you guys, maybe we could stop with moles. In fact, let me do that. I'll tell you what it is. So if I told you we knew how many moles of oxygen we have, so this is going to be 5 bonus. This is going to be the bonus problem. Okay. No marker. Oh man. Okay. If I asked you as a bonus and I said, okay, well, you know you have 133.4 grams of oxygen, and I wanted to say, how many liters of oxygen is that going to be? Okay. If I asked you, okay, how many liters of oxygen is it going to be? You better know how to do it, because that's something that you could get asked. So this is 5 bonus. So I'm going to take our number from the last problem, 133.4 grams of oxygen, and I were to ask you, okay, well, what's the volume going to be? How many liters of oxygen is that? Okay, we want to find out how many liters of O2 is it. Now, I talked about this in the last video, and I went kind of fast. That's why I want to review it just a little bit. This is not anything you need to write down on there, but I do want you to know how to do it, because it might show up on a test or something. So liters of oxygen is what I'm looking for. Now, if you remember, if you look on your green sheet, it says this. The volume of any, of 1 mole, 1 mole of any gas at standard temperature and pressure, STP, standard temperature and pressure, is equal to 22.4 liters. Okay, we talked about it briefly. Okay, volume of 1 mole of any gas at standard temperature pressure is 22.4 liters. So what that means then is we can use that to tell us how many liters of oxygen. But again, just like if you're going from some substance to another, you got to go through moles. We got to have moles in order to find this. Moles are magical. You can go from something to something else, but you've got to go through moles, okay? Unless the problem's asking for grams, and then you do that last conversion. But even if you're going from something to grams, you still got to use moles. So here's what we're going to do. I'm just going to show you how to do this problem just in case you see it. But it's really not that bad. You just have got to understand what this means, and I'm going to show that to you. So the first thing I'm going to do is I've got to go from grams back to moles again. So I'm going to put grams of O2 down here on the bottom. I'm going to put moles of O2 on top, because by doing that, I'll cancel the grams. We know from the last problem this was 32.0 grams for every 1 mole. Hopefully you remember that. But the only other thing that we're doing now is we're saying, okay, well, now I'm going from moles. Here, look, I'll show you. This cancel. Grams of oxygen just cancel. But now we're going from moles to liters. Okay? Yeah, and we're going to find that. I'm doing it in one step, but we are trying to find how many moles there are. And so now what I'm going to do, though, is I don't want moles. I want to know how many liters it is. So look, I want to get 2 liters, not 2 liters like a 2 liter. I want to get TO. I'm trying to go towards liters, and I'm trying to cancel out my moles of O2 down here on the bottom. And that's where this comes in. And again, if you don't know where it is on your green sheet, it's on the very first page underneath where it says chemistry reference tables. Down here, it says volume of 1 mole of any gas at standard temperature and pressure, 22.4 liters. So look, 22.4 liters, 1 mole. It's just another conversion factor. So don't be confused by it. So if I do this in my calculator, okay, I can find out, all right, 133.4 divided by 32 times 22.4, and I get 93.38 liters of oxygen. That's a lot. That's a lot of 2 liters. That is 46.72 liters, okay, filled with just pure oxygen gas that was formed or could be used, consumed in this reaction. Okay, so anyway, this is just kind of a bonus. That's just something for you guys to think about. Let's move on to part 6. Problem 6, excuse me. I've been over the whole daggone thing because you guys wanted it. Still got 11 people that are at least halfway watching or have it open in another tab while they're looking at memes in another tab. All right, let's take a look at problem number 6. It's not bad. Using the following equation, we have 1 mole of sodium iodate, okay, plus 6 moles of hydrogen iodide is going to give us, oh crap, 3 moles of iodine gas plus 1 mole of sodium iodide plus 3 moles of H2O. Sorry, I should have written that on the next line, and I didn't. Yeah, I'm trying not to do 2 hours. So we've got this full balanced equation. Remember, blanks just mean 1, okay? So blanks just mean 1, all right? And so, pretty useful. Calculate number of grams of iodine. Okay, I'm looking for I2. Hey, we did this earlier, but it was a different reaction, so it's going to be different. Can be made from 16.4 grams of what? Sodium iodate. Okay, so we're starting with grams of sodium iodate. We're trying to get to grams of just iodine gas. All right, so let's do it. Same thing as before. I'm just going to set everything up and leave it hollowed out, and we'll put in some values in a second. So my game plan. First thing, I know I need to go from grams to moles. Moles are so much more useful than grams. So the first thing I want to do is I want to cancel out those grams. So I'm going to put grams of sodium iodate down here in the bottom. I'm going to put moles of sodium iodate on top. Okay, we'll be back to that in a second. But I don't want sodium iodate. I want to get to iodine gas. So I'm going to cancel out my moles of sodium iodate down here in the bottom. And I'm going to put my moles of iodine gas up on top. But I don't want moles. If I were to stop here, I would just be left with moles of iodine gas. That's not what I want. Okay, that's not what I want. I'm sorry for your cat distraction. I'm trying to get to grams of iodine. So the next thing I'm going to do is I'm going to start, well, I'm going to put moles on the bottom. I'm going to put grams on the top. So as you guys can see, I must not be writing very straight. We're trying to get to grams of iodine gas all the way over here. And this is how we're going to do it, using this conversion factor. So let's plug some numbers in. Wow, Drew, you're so nice. So we have 16.4 grams. We need to find out what this number is going to be. Same thing as normal. Okay, you use the periodic table. Iodine's a big number. What is it? $126.90. plus 3 oxygens. There's a 3 there. Okay, so let's add all this up, make sure we get the same number. 22.99 plus 126.9 plus 3 times 16. Whew! Let's just call that 198, guys. Let's just keep it simple. But 198 grams per mole. I just rounded it. All right. So once again, I'm going to put it in 198 grams per mole. Per just means 1 mole, as we've said. Next thing, I'm going to look up above, and I can see that, all right, for every 3 moles of iodine, it is going to consume 1 mole of sodium iodate. Okay. Tony, I said you need to call the tech office. The information is on Google Classroom, but you need to call tech services and tell them your OneNote is being weird. I promise, I've been working off your page this whole time in your folder. Are you in your Unit 4 folder? Because that's where I sent it. All right, last thing is iodine again. Because there's 2 iodines, we're just going to do 2 times 126.90, just like we did before. And we get 253.8. And so once again, 253.8 grams per mole, way down in the very far corner. I know y'all can't see it. There we go. So I'm just going to call it 254. 254 grams per mole. So we've got everything set up. Everything is in its place. I'm going to go ahead and start counting. And the reason I know everything's in its place is, look, grams, canceled. Moles of sodium iodate cancels with moles of sodium iodate. Moles of iodine cancels with moles of iodine. And we're left with grams of iodine there at the very end. So everything's working out. So I'm going to do the math. And I want somebody to check me. Don't just let me get the same answer. I want you to check me. You type in what you guys get. I'm not even going to write my answer down until I see at least 2 of you that tell me what you got for this problem. Not even going to write my answer down. Okay, that's 1. That's 2. Good. So yeah, I got 63.1, and so that's what I'll write in red. Yeah, I got 63.12. So I agree with that. That's more precise. There we go. There we go. And look, when you guys are doing any types of problems for my class that are like this, which I call these conversion problems, and pretty soon we're going to be doing some chemistry math problems. They're a lot easier than this, in my opinion. The chemistry math that we're going to be doing later, a lot easier than this. But when you are doing your worksheet, if you do not have this, I am not going to give you credit. Because a lot of you are going to try and do it. You're going to try and just put 63.12, done. No, I have to see that you understand what you're doing, because I'm not there in person to check you. So you've got to show all this work so I can see it. And honestly, I'd make you show this work if we were in person, face to face too. Okay, so make sure you have that there at the end. Okay. Okay, and now the next question, okay, or the next thing we're going to do, we're just going to open up Q&A. So if you're done and you're like, well, I got what I wanted, I just wanted all the answers, and I'm going to leave the stream, you can, but now's a good chance to ask me Q&A. You can ask me anything, and I will try and help. Okay, next session, I've kind of just been doing these like as needed. So we'll see. We'll try and do a couple more next week. What I've learned from this experience is it's better for me to do them in the afternoon, even if it's after 4, apparently, even though that's outside of school hours. Y'all seem to like that better than doing it early in the morning. No, I do not play Call of Duty Warzone. It's stupid. Okay. Any questions though, guys? Type them in. I'll answer them. We got a few more minutes, and then I'm going to cut this thing off. Writing down my timestamps. Okay, what's your question, Tyler? Oh. Tony, she's not here, but yeah, probably. She's a lot more experience. No, what's the word? She's a lot more empathetic. She's a lot better at talking to people and dealing with emotions. How do you use avocados? Okay, so yeah, if you're doing vocab and you want to use avocado's number in a sentence, well, so we don't want to just reuse the definition because that'd be bad. Okay, let's try this. Using Avogadro's number, I was able to find out. Underline your words, guys. Use the word in a sentence and underline the word. So using Avogadro's number, I was able to find the number of molecules and 3 moles of NH3. There we go. Sentence, check. Vocab is due sometime next week. It's hard to say when right now. But like by now, you should be like 3/4 of the way to almost done with it. So you should be about 3/4 of the way done or almost completely done with it. Well, Kevin, if you got any more, I mean, I'll give y'all a couple more sentences if that's helpful. May 15th, no. So the way that you guys are going to turn it in, and I think I typed it on Google Classroom at one point, is you'll probably end up taking pictures of it. Okay, bye. See you, Tony. Yeah, it's been real. It's been good, but it hasn't been real good. Because I don't know that we will be back on May 15th. There's no way to know. So what I'll probably ask you guys to do, and you should know how to do this by now, is to take pictures of your vocab, and I'll give you a place to turn it in, like in your folder. Okay? I'll give you a way to do that, and I'll put that in there. Why is that not loading? Activated complex. That's a good one. That's a good one that I definitely have an answer to right now. I'm thinking. Leave me alone. All right. There you go. Best thing I got for you. Any other questions? Drew, if you haven't even started, better get on it. You're welcome, Kevin. If you can think of any more, let me know while I'm here. I'm about to get off in about 5 minutes if nobody says anything. Or sooner. If you guys just start leaving, if you're done, leave. Net ionic equation. Hold on, let me check the definition so I don't just give you the definition again. Oh, I know a good one. I know a good one for net ionic equation. There you go. And net ionic equations is something I am definitely going to cut. Like it's still good that you have it in your vocab and you've at least seen it before. But I am definitely going to cut that material because I do not have. I'm not going to try and teach that over the internet. It's not essential. And it's honestly just annoying. Any other questions? We got 7 of you still here for some reason. Okay, I will give you 30 seconds, and if nobody says anything or doesn't have any more questions, I'm going to leave. Ionic? Ionic is a... I don't remember that. Let's be at the bottom. Do you mean just ionic equations? Is that your question? Oh, okay. So here you go. All right. There you go. Ionic equations write out compounds as ions. And then I gave an example, but I still put a period. You don't know how I am about that. I still put a period down here. Drew, I will write you up through the internet. But yeah, I hope it was helpful. Okay. Any more? I'll give you 30 more seconds. Otherwise, I'm going to grade some papers. Good one. Percent composition. Well, if you want an easy one for percent composition, I hope you understand now, Drew. If you honestly just want an easy one test, I would just draw that equation or write out that equation that I gave you in the Quizlet that shows you some type of equation. But alternatively, another good way to think about it is you can do a pie chart. So like if I were doing one, I'd be like, all right, well, let's say we're doing one for H2O. Let's keep it simple. I don't have that off the top of my head. 1 second. There you go. So that's another one you could do. All right. Anybody else? There's 4 of you that are still sitting here. Okay. Anybody else? 30 seconds. If nobody says anything, I am going to end it. Okay, that's it. Bye, guys. Have a good one.